Today we're continuing section 6.4, graphing logarithmic functions. First, let's talk about this basic graph, y equals log base b of x minus h plus k. The minus h does horizontal movement, left or right. So you may want to make yourself a note that when this is plus h, it moves left, and when it's minus something, it moves right. And that horizontal movement is going to affect the asymptote. The asymptote is going to be whatever that h value is. So your asymptote is going to be at x equals h. So if this says x minus 2, that means it moved right 2, your asymptote would be x equals 2. If it said x plus 3, that actually means left 3, your asymptote would be at x equals negative 3. So however that graph moves left or right, that moves the asymptote. The plus k is going to move the graph up and down, and that's perfectly normal. Plus k moves up, and minus k moves down. If there's a number in front, it's going to stretch or shrink it, just like it does any other time. A negative in front is going to flip it over the x-axis, so a vertical flip. A negative in front of the x inside the log, which we don't see very often, but every once in a while we do. A negative in front of the x inside the log is going to flip it so that the graph is over on the left side, and that would also flip your asymptote. Your asymptote and your domain are tied to that h value. So whatever your domain is, or whatever your asymptote is, your domain is going to be x is greater than that number. And your range is all real numbers. Using the calculator, if you are using a TI-84, most of them are like this, the TI-84 Plus. The TI-84s have a feature called log base, and you access that feature by pushing the alpha button and then the window button. And then option number 5, alpha window 5. So alpha window 5, and that gives you that log template to put the base and the number inside the log into. The problem is that only exists on the TI-84. It doesn't exist on the TI-83. It doesn't exist on scientific calculators. So what if we need to do a log with a scientific calculator or with a TI-83 calculator, like an older style calculator? We can use the change of base formula. If you have the log base c of u, you can use the normal log button and do log button u divided by log button c. You always do the stuff inside the log on top and the base is on the bottom. So if I do this in my calculator, log base 6 of 15, I can type in log base 6 of 15, and I know that it is 1.511. But what if I don't have this TI-84? You can do log 15 divided by log 6. So normal log button 15, close your parentheses, divided by log button 6, close your parentheses. We get that same thing, 1.511. Number 11, it would be log 7 divided by log 3. Try that out in your calculator, see what you get. Then try number 12 in your calculator, see what you get, pause the video, play once you're done with 11 and 12. If you're struggling to get the correct numbers in your calculator, please send me an email or chat with me on Teams or post a reply on Teams so that I can help you figure out how to use your calculator to get this correct. Now, if you have a TI-83, that would also help you with graphing. And I'm going to record a specific video for graphing with the TI-84, graphing with the TI-83, and graphing with Desmos. So I will have a video, a short video for each of those methods, and I will let you choose which of those that you want to watch. So I'm going to do number 1 using the TI-84. I'll do number 2 using Desmos just to show you how we would do these. Okay, so number 1, if we graph using a TI-84, we want alpha window 5. We want to get that log base. So log base 2 of x minus 2 outside of the parentheses plus 3. Now, you can get a lot of this information without ever looking at the graph. In fact, you could fill this stuff in before you even start. You don't need a graphing calculator to fill this in. Your asymptote comes from what's inside the parentheses, and so does your domain. So because this means right 2, I know that my asymptote is at 2. And I don't see any negatives switching anything up, so I know that my domain is going to be x is greater than 2. That means we have a vertical asymptote here. The graph can't go any farther to the left than that line. So I see this picture on my graph. I'm going to go into the table, and there's all those errors. I like to grab the first point after the errors. So 3, 3, 4, 4. That next point's kind of oogie. How about 6, 5? Yeah, I said oogie. What do you want to do about it? 3, 3, 4, 4, and 6, 5. Okay, so this is going to continue going up in that direction. And left of that point, it doesn't show it very well on the graphing calculator just because of the pixelation of it, but it's going to get closer and closer to that asymptote, but not cross it. Do not cross your asymptote. Okay, the hardest part of this entire thing. The range is all real numbers. Okay, let's do that same thing with number 2. So in a browser, you go to www.desmos.com. You click Start Graphing, and it will pull up this graph. It says f of x on here. Remember, f of x is just a fancy way of saying y. You could actually type in f of x equals if you wanted to, but it's just easier to do y equals. Y equals 2. Type in log. Then you need to type shift, hold the shift button, dash. Shift dash moves that down. That's the underscore that moves it down and lets you type in a base. So our base is 5. I push the right arrow to get out of the base, and then parentheses x plus 1, close my parentheses. Now it graphed it for me, but remember, you don't need the graph to get the asymptote, the domain, and the range. The range, you know right now, is all real numbers. This thing, the plus 1, means left 1, so our asymptote is going to be at -1, and you can go ahead and draw that in on your graph. This graph is on the right side of that asymptote, so x is greater than -1. To get some points, in Desmos, you click the little wheel, the little settings wheel, and then convert to table. Now the problem is it's going to always start, it's going to give you from -2 to 2. So you may have to type some numbers in that you want. Like I really like that 0 one, so I'm going to stick with 0. And then on the next one, maybe 1, 2, 3, 4. I'm just arrowing down and typing in numbers. So I see that the point 0, 0 is going to be good. The point 4, 2 is going to be good. That's only 2 points though, so I might decide, oh shoot, what did you do? It moved on me. I might decide to go over here and type in somewhere, doesn't even matter where. Let's do 5, no, 6, no, 7, 8, 9. Okay, none of those are very good. So I guess I'm just gonna pick like, 6 and 2.4. So 0, 0, 1, 2, 3, 4, 2, 6, 2.4. So this graph really flattens out, and you can see that in the picture. And on the left, it's going to curve around and get closer and closer to that asymptote. I don't know if you can convert it back. I think you can just click undo until it goes back to the equation. Yeah, you can. You can click undo until it goes back to the equation, but you don't really need to go back to the equation. Number 3 looks different because instead of log, it has ln. So if you're working with the graphing calculator, This is actually really easy to put in. And if you have a TI-83, you can definitely put this in. So to type this one in, ln button, x plus 3, close your parentheses, minus 4. But because ln is the natural log, its base is e, that means that pretty much all of the points are going to be pretty nasty. There's not going to be very many nice points. They're all going to be decimals. You'll just have to deal with that. On Desmos, same thing. You go into your equation and you just type in y equals ln parentheses x plus 3. Move outside of your parentheses, minus 4. And there's that graph. You can convert it to your table. And I like the point -2, -4. I think I'll take the point 0, -2.9, and maybe 2, -2.4. Asymptote, domain, and range works exactly the same for ln because it's still a log. ln is still a log graph. It's just log base e. So our asymptote still comes from whatever's in the parentheses. This thing moved left 3, so our asymptote is at x equals -3. The graph is on the right side of that, so the domain is x is greater than -3, and our range is still all real numbers. It's a really good idea to dash that asymptote in so that you don't go past that asymptote, and then plot a couple points and draw it in. I want you to try number 4 on your own. Try it completely on your own using Desmos or whatever. Get it graphed, pause the video, play the video when you're done. This one's a little bit weird because it is flipped up. Well, it's like flipped over the x-axis. Your asymptote is still at 1, so if you look as you get up farther, and the cool thing about Desmos is that you can just take your finger and drag this, and you can see as you go up, it looks like it's on that vertical line x equals 1, but it's just getting closer and closer and closer to it. But on Desmos, you can move this graph around, you can zoom in, you can zoom out, you can really see a lot just using the gestures that you're used to doing on your tablet screen. Okay, your assignment is going to be in Big Ideas Math today, so I want you to make sure you go to Big Ideas Math. It is going to be a fairly short assignment. It's basically just matching some equations to their graphs. And so really, I want you to look carefully at where the asymptote would be to help you in matching those graphs. The worksheet that I gave you before spring break, worksheet 3, I would like you to also pick a couple of those and just try them. I want you to get comfortable graphing because you're going to need to be able to know how to graph logarithmic functions. So Big Ideas Math, there's going to be an assignment in 6.4 for you. And then I also want you to pick a few on worksheet 3 and give those a try. I will be posting an answer key for that worksheet 3 on Teams on Friday.